Okay class, good morning. But before anything else, may I request everyone to please bow down their heads for the prayer. Amen. So before anything else, let me first introduce myself to you. I am Rex Estrada Obida, 23 years old. I just graduated last 2023 with a degree of Bachelor in Secondary Education major in Mathematics here at WMSU April SU. So, before anything else, let me check first your attendance. So I guess everyone is present. So for today's discussion, our topic is all about mathematical induction. So before that, let me present first to you the objectives for today. At the end of the lesson, the student will able to learn and understand mathematical induction, solve and prove mathematical equations. So what is mathematical induction? So mathematical induction, it is the mathematical technique which is used to prove a statement, formula, or a theorem is true for every natural number. So the principle of mathematical induction is used to prove that a given proposition is true for all positive integer numbers greater than or equal to some integer n. Let us denote in the proposition in question by P of n, where n is the positive integer. The proof involved two steps. The two steps are, first, we must establish that the proposition P of n is true for the lowest positive value of the positive integer n. Second step, we assume that P of k is true and establish that P of k plus 1 is also true. So, here are some examples. So, example number 1, we have 1 plus 3 plus 5 plus plus 2n minus 1 equals n squared. So, by the given equation, we must find, we're going to get the value of n by letting the n equals to 1. So, let n equals to 1. So, we need to let n to 1, so we need to copy the first value of the given equation. So, we have the 1 equals the value of n squared by letting the n into the value of 1, so 1 squared. So, 1 equals to 1 squared is 1, so it's equal. So, we need, again, we're going to let n equals to 2. So, let n equals to 2. So, and the two number, we need to copy, we need to get the two decimal number, the two place number in the given equation, the 1 and 3. So, we have 1 plus 3 equals the n squared. So, 1 plus 3 equals 4. So, n squared, we need to substitute the n by 2. So, 2 squared equals 4. So, they're equal. And then, we let n equal to 3. So, by letting n equals to 3, we need to get the 3 place value of the given equation, the 1, 3, and 5. So, we have 1 plus 3 plus 5 equals n squared. So, 1 plus 3 equals 4 plus 5 equals to 9. N squared, by letting the n to the value of 3, 3 squared. So, we have 9, 9, so equal. So, with the given equation, we can conclude that the P of n is true. Since we already knew that the P of n is true, so let's assume that n equals to 1 is also true. So, by letting the n equals to k is also true, we need to substitute the value of the variable n into the variable k. So, the equation will be look like this: 1 plus 3 plus 5 plus plus 2k minus 1 equals k squared. So the equation of assuming the n equals to k will be look like this. So if we're going to prove this, we need to prove that n equals to k plus 1 is true. So upon proving this equation, we need to substitute the value of k into 2k plus 1. So the equation will look like this: 1 plus 3 plus 5 plus dot 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 plus 2k plus 1 minus 1 is equals to k plus 1 squared. So upon proving this equation, we need to substitute this value into the given value of k squared. So we have the k squared plus this equation 2k plus 1 minus 1 equals 2k plus 1 squared. So in the next step, we need to copy the k squared, multiply the 2, distribute the 2 to the k plus 1, so we have plus 2k plus 2, copy the negative 1 equals, so if we're going to simplify the k plus 1 squared, we're going to use the FOIL method. So the product will be k squared plus 2k plus 1. Since there are like terms in this equation, so we need to simplify them. So we have k squared plus 2k. Since 2 minus 1, they are like terms, so we need to copy the sign of the bigger number and then subtract. So we have 1. And then copy the equation of k squared plus 2k plus 1. So this is the final answer. So therefore, the given equation is possible to all positive integers. So we have another example. We have 1 plus 4 plus 10 plus plus 3n minus 2 is equals to 3n minus 1 over 2. So in this equation, we need to get the value of n by letting the n equals to 1, 2, and 3. So let n equals to 1. So since we let n equals to 1, we need to copy the value of the first term. So we have 1 equals, by letting the n into 1, so 1 over 3 times 1 minus 1 over 2. So we have 1. So 3 times 1, 3 minus 1 over 2. So we have 1 equals, by subtracting 3 minus 1, so we have 2 over 2. So 1, 2 times 2, 2 times 1 is 2 over 2. So we have the divide, so 1, so they're equal. So we let n equals to 2. So by letting n equals to 2, we need to copy the first and the second value of the equation. So we have 1 plus 4 equals, by letting n into 2, we have to 3 times 2 minus 1 over 2. So 1 plus 4 equals to 5. So we have copy the 2. Since 3 times 2 are 6 minus 1 over 2. So 5, 2, 5 over 2. So we have 5. 5 times 2, 10. Divide 2. So 5 equals to 5 are equal. So we need to let n equals to 3. Let n equals to 3. So let n equals to 3. So by letting n equals to 3, we need to copy the first, the second, and the third value number of the given equation. So we have 1 plus 4 plus 10 equals, by letting n into 3, so we need to substitute the value of n into 3, 3 minus 1 over 2. So 1 plus 4 equals to 5 plus 10 equals to 15. So copy the value of 3. So 3 times 3, we have 9 minus 1 over 2. So 15 equals, copy the value of 3, subtract 8, 2. So 15 equals 24. 3 times 8 equals to 24, divide 2. So 15 equals 12. So in this equation, we didn't get the exact value of letting n equals to 3. So we can conclude that the given equation cannot be proved. We can conclude that the given equation is not possible to all positive integers. So another example, we need to have another example that prove that we can prove that all positive integers are possible. So by letting the example of 1 plus 4 plus 7 plus dot 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 plus 3n minus 2 equals n 3n minus 1 over 2. So with this equation, we need to get the value of n by letting the n to 1. So by letting n into 1, so we need to copy the first value of the given equation. So we have 1 equals, by letting the value of n into 1, 1, 3 times 1 minus 1 over 2. So 1, 3 times 1, we have 3 minus 1 over 2. So 1 equals to 1. 3 minus 1, we have 2 over 2. So 1 times 2, 2 over 2. So 2 divide 2, so 1. So by letting the value of n into 1, so it is true. So we need to let n into 2. So let n equals to 2. So by letting n equals to 2, we need to copy the first and the second value of the given equation. So we have 1 plus 4 equals, by letting the value of n equals to 2, 3 times 2 minus 1 over 2. So 1 plus 4, we have 5 equals, copy the value of 2. 3 times 2, 6. Copy the minus 1, divide 2. So 5 equals 2. 6 minus 1, we have 5. 2. So 5. 2 times 5, we have 10 over 2. So 5 equals to 5 is true. So by letting n equals to 2, it is true. So we need to let n equals to 3. So by letting n equals to 3, we need to copy the first, the second, the third value of the given equation. We have the 1 plus 4 plus 7 equals, by letting the value of n equals to 3, 3 times 3 minus 1 over 2. So in this equation, we need to add 1 plus 4 equals to 5 plus 7 equals to 12. So 3, copy. 3 times 3, 9 minus 1 over 2. So we have 12 equals 3 over 2. So 12, 3 times 8, 24. Divide 2, so 12. 12 equals to 12 is true. So by letting n equals to 3, we can conclude that the given equation is true. So with the given equation, let assume that n equals to k is true. So by letting n equals to k is true, so since the value of n is true, so we need to assume that n equals to k is true. By assuming that p of k is true, establish that p of k plus 1 is also true. So by assuming, we need to substitute the variable n into k. So we have 1 plus 4 plus 7 plus dot 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 plus 3k minus 2 equals k 3k minus 1 over 2. So upon getting the assumed number of k, n equals to k is true, so we need to prove this equation that it is also true. So upon proving this equation, we need to rewrite it by 1 plus 4 plus 7 plus, so by proving it, we need to substitute the value of k into k plus 1. So we have 3k plus 1 minus 2 equals k plus 1 3k plus 1 minus 1 over 2. So we follow this formula upon proving the equation. So since we're going to substitute this given equation to the given number, so we have the k equals to 3k minus 1 over 2, and then copy this equation, so plus 3k plus 1 minus 2, and then with this equation, k plus 1. So upon simplifying this equation, we need to distribute the k to this. So we have 3k squared minus k plus, distribute the 3, so we have over 2. So we have 3k plus 3 minus 2 equals, so k plus 1, so we have 3k plus 3 minus 1 over 2. So copy 3k squared minus k plus 3k plus 1 equals k plus 1 3k plus 2 over 2. To cancel the 2, multiply both sides by 2. Multiply by 2, so cancel. So we have 3k squared minus k plus 6k plus 2 equals, distribute, so we have 3k squared plus 2k plus 3k plus 2. So combine like terms, we have 3k squared plus 5k plus 2 equals 3k squared plus 2k plus 3k, we have 5k plus 2. So we can conclude that the given equation is possible to all positive integers. Since we're done about my discussion, so here's an activity for you to test if you are really listening about my discussion. So you are given 10 minutes to solve these two equations. All you need to do is to prove if it is true or not. So before I will end this class, I will give you an assignment to pass on next week. So I want you to construct your own 3 equations and prove it using mathematical inductions. So class, that would be the end of my discussion. Thank you.